Okay, for this video we want to find the equation of the parabola described, find the points that define the lattice rectum, and then graph the equation. So we're given that the focus is at 0, 2 and the vertex is at 0, 0. So that tells us that we have a vertical parabola, and the vertical parabola opens up or opens down depending on the coefficient we'll see later. And then we have the ones that open to the right, to the left. So let's look at the general form, or the standard form. Equations of a parabola: vertex at HK, axis of symmetry, parallel to the coordinate axes. Now if the vertex is at 0, 0, then this first one would just be y squared is equal to 4ax, and it will open to the right. The second one, again, vertex at 0 would just be y squared equal to minus 4ax. This would open to the left. And then the next one, again, vertex at 0, that would become x squared is equal to 4ay, and this would open up. And this last one here, with vertex at 0, 0, would be x squared is equal to minus 4ay, and this would open down. So again, you can pause the video at any time and see if you can work this out. This one is pretty straightforward. Now we know focus is at 0, 2, that's given. So the equation then that we're looking at, because the vertex is at 0, 0, is x squared is equal to 4a y. And remember, a is always positive, and you use the a to find your focus and your directrix. That means this 2 here has to be a. The vertex is always in between the directrix and the focus, and if it's a vertical parabola, the directrix is horizontal. So this would be y equal to minus a. In this case, a is 2, so this would be negative 2. The equation, of course, is pretty straightforward. In this case, because all we have to do to get the equation is replace the a by whatever the value is. In this case, 2. So 2 times 4 is 8. So x squared is equal to 8y. That's the equation. And then it wants us to define the points that define the lattice rectum and graph. So that's the first part of the problem then. And then for the graph, origin is the vertex, so it should be here. There we go, 2 units up, 0, 2. And again, the equation was x squared is equal to 8y. Focus is right here at 0, 2. So because the vertex is at 0, 0 and the focus is 0, 2, we know it opens up. If this had been a negative, it would open down. So basically this is going to go like this. And like this. And the lattice rectum is this segment. It goes here. So it wants this point here and this point here. So over here, this is x squared then. You can see the y value here is going to be 2, so we replace the y by 2, we get 16. So x is equal to plus or minus 4. So the points that define the lattice rectum here, this actually tells you how wide the parabola is at that particular area. And my graph's a little bit off here, but here we go, 4 and 2. And over here on this side, -4 and 2. And of course, we already said the directrix is at the other end. So the focus is here, the directrix is 2 units this way. This is y equal to -2. So if I go 2 units down here, that's my directrix. And of course, by definition, the parabola is a set of all points that are equidistant from a fixed point, which is the focus, and a fixed directrix. So if I take any point on this parabola, and of course I won't look at it because my graph's a little bit off, but if I take this point right here, say, then the distance from this point to the focus and from the directrix, so this distance, perpendicular distance right here, would be the same. You can see that for the vertex, it's on the parabola, so the distance from the vertex to the focus and to the directrix is the same. This is your directrix here. So this one here is pretty straightforward. If the vertex is not at the origin, then it's a bit different. But whenever the vertex is at the origin, your axis of symmetry will go right through the vertex and the focus. So in this case, parabolas that open up or open down will have axis of symmetry will be the y-axis. For parabolas that open to the right or to the left with vertex at the origin, axis of symmetry will be the x-axis. Thanks for watching. We'll see you next time.